Alrighty, welcome to my discrete math test number 3. Let's go. Problem 16. We're going to prove that n mod 2 equals 1 minus negative 1 to the n over 2. We're going to find and prove a similar expression for n mod 3 in the form of a plus b times w to the n plus c times w to the 2n, where w is a complex number negative 1 plus I times square root of 3 all over 2. And we're given the hints that w to the third equals 1 and 1 plus w squared equals 0. So our goal is to prove that n mod 2 equals that, find a similar expression for n mod 3, prove that our similar expression works, and celebrate, because yay! First things first, we're going to prove that n mod 2 equals this thing. Look at when n is even. When n is even, we know that any negative number to an even power is just the positive version of that number, or whatever. So we have 1 minus 1 equals 0, and 0 divided by anything is 0. The same thing for 4 mod 2. Look at that, it's 0. Let's crunch the numbers, see if that's true. Using modular arithmetic, we find that 3 mod 2 is in fact 0, and that 4 mod 2 is also 0. So with this we know that when n is even, n mod 2 is 0. And let's look at when n is odd. When n is odd, we know that a negative number to the odd number is just negative. So we have 1 minus negative 1, which is just 1 plus 1, which is 2, and 2 over 2 is 1. So 3 mod 2 is 1, and with that logic, 5 mod 2 is also 1. Let's also crunch numbers, see if that's true. With the magic of modular arithmetic, we find that 3 mod 2 is in fact 1, and 5 mod 2 is also 1. So when n is odd, n mod 2 is odd. So what does this mean? This means that n mod 2 does equal that lovely equation for all n. Perfect! Yay, proof is done, we're done. No, we're not. Not so fast. We need to find a similar expression for n mod 3. Lovely. Yeah. So let's remember what we're given. We're given that we need to use this form. We're given what w equals. W to the third is equal to 1, and 1 plus w squared equals 0. So let's look at when n is 0, n is 1, and n is 2. So when n is 0, we have 0 mod 3 is 0. With modular arithmetic, we know this is true. It's just 0. So let's just plug that in for the formula we're given. Well, anything raised to the third power is 1, so we have a plus b plus c equals 0. Crazy. This is going to be our equation number 1. Keep this in mind. Now let's do the same for when n is 1. When n is on, we have 1 mod 3 equals 1. That is true. So let's plug in 1 to the equations, and we have a plus b to the w, b times w plus c times w squared. Well, w squared, that's weird. Pay no mind, because we have this lovely equation we're given. We can just move things around to find that, oh, it's not connected. Okay, to find that w squared equals negative 1 equals negative w minus 1. So with that, we can just plug that bad boy in and distribute, combine like terms, and this is our equation, a plus b minus w times c minus c, minus 1 equals 0. This is equation 2. And we have when n is 2, we have 2 mod 3 equals 2. And plug some things in. We have some weird things here, w squared and w to the fourth. Strange things. Well, let's remember w to the third equals 1. So we know that w to the fourth equals w to the third times w to the 1. So we can just replace that and have w to the fourth, times 1. So we just have this. And then, of course, we had that from the one before. We can just plug those bad boys in. Lovely, lovely. Distribute, combine like terms. And here we have our equation 3. And let's solve for a, b, and c. To do that, let's just add the 3 equations that we found. There we go. Let's cancel out things, combine like terms, yada yada. Our b's cancel out, our c's cancel out, our b minus c's cancel out, and we're left with our lovely a's and our constants to get 3a minus 1 equals 0. Doing some lovely algebra, we get a equals 1. Fantastic. Let's plug that into equation 1. And then that gives us 1 plus b plus c equals 0. Let's just multiply that by w to make our lives easier. And then let's do the same for equation 3. And then let's subtract the two equations and simplify it a little. Now let's solve for b to get this disgusting looking thing right here. Well, let's just simplify that real quick. Multiply it by some fancy looking 1. Do some great algebra, fab, foiling, factoring, all that jazz. Get, oh, there's a parenthesis, okay. Get that b equals w minus 1 over 3. Fantastic. Well, knowing this, we can now solve for c. Plug it into equation 1 because that's the easiest one. Combine things to get that c equals negative w minus 2 over 3. Fantastic. So we can just plug it in to the equation that we're given, and we can even simplify it a little further to get that n mod 3 equals 1 plus 1 to the third times this. Now we're done. We found the expression. Hooray, hurrah. Again, not so fast. Now you have to prove it. Oh no. It's okay. To prove it, we can just look at it. We can look when n is 0. Let's see if that works. So when n is 0, we can just plug 0 in for n into the equation to get this lovely looking thing there. And so since that's just the entire thing here, this equals 1, we can just ignore them. And we have this. Well, if we just look, we have a minus this, so that's minus a negative, so these parts, oh wait, I have my blinker on, there we go. These parts cancel out, so we don't have to worry about the complex number actually. So we just have negative 1 minus 2, which is just negative 3. So we have 1 plus, well, negative 3, negative 1 basically, 1 minus 1. So 0 mod 3 is 0, which is what we assumed in the first place. Now, let's do the same for when n is 1. Plug things in. Wait, why is it? Oh, there we go. Plug things in, and let us know. I'm just gonna let you guys know that when we have the complex number minus 1 times the complex number, it's negative square root of 3, and same for this. It's also equal to negative square root of 3. So we have negative square root of 3 minus negative square root of 3. We have such a 0. So 1 plus 0 is just 1. So that means 1 mod 3 is 1. The same for this. Blah, blah, blah. We get 1 plus 1, which is 2. Voila! It works. Happy holidays. Yay!